So my name is Matthew Skelton. I'm the co-author of the book, Team Topologies, Organizing Business and Technology Teams for Fast Flow. And I'd like to share with you some ideas today about how HR, or the Human Resources Department, People Department, can actually end up being the accidental architects of our software systems. It sounds really strange, right? But let me share with you why this might be the case. So the book Team Topologies came out just over a year ago, September 2019. It's published by IT Revolution Press, the home of books like DevOps Handbook, Phoenix Project, Project to Product, and Accelerate. It's a great family of books. Before we go any further, let's look at this word topology, because it's not very familiar. So it comes from a Greek word meaning kind of where things are placed. And the way we interpret it these days is it means the way in which constituent parts are interrelated or arranged. So if we're thinking about team topologies, this is the way in which teams are interrelated or arranged. And this is in the context of a fast flow of change for building software systems. And the ideas that, that are contained in the book have been really useful for lots of organizations around the world. So the ideas that we were working on before the book was published were used by companies like Netflix. So Philip Fisher-Ogden, who's Director of Engineering at Netflix, said, thanks for your insightful articulations of DevOps topologies. They inspired many discussions and helped us to think about what model Netflix teams could be using. They're also used at places like Condé Nast, the big publishing house. Crystal Hirschhorn, she was Director of Engineering there until recently, and she said, your topological model resonated extremely well with both the development and the operations sides, and she liked the balanced arguments for different perspectives for each pattern. The book has been described as innovative tools and concepts for structuring the next generation digital operating model. So these are strategically important concepts and ideas that we can apply at least inside IT, and in practice, probably in other parts of the organization too. Okay, so let's have a little think about who designs the architecture of the software systems. Is it software developers? It can be. Is it software architects? Could be. By the way, this is an official picture of a software architect. They tend to look exactly like this, really happy all the time. I'm joking. Or could it actually be the HR department, people? That sounds odd. But actually, the HR department can act as accidental architects of the software system. This is an actual photograph of me when I first realized this a few years ago. Let's explore why this might be the case. First, we actually need to look at something called Conway's law. So in 1968, Mel Conway, who was then, I think, working for a large computer corporation, he wrote a paper in which he published in a journal, wrote an article that said, any organization that designs a system, broadly defined, will produce a design whose structure is a copy of the organization's communication structure. Now, this has been quite well known recently, and in the last few years has resurfaced as a kind of guiding principle. But let's just take a few minutes to check this. Is it really true? Let's have a look. There's lots of people who have been quite skeptical about this. And one of the things that we did when writing the Team Topologies book was to actually look at the academic research in this kind of area. In 2012, there was a research paper published by McCormack and colleagues, and they did a study about closed source and open source software. And this was one of their conclusions. Products tend to mirror the architecture of the organizations in which they are developed. This dynamic occurs because the organization's governance structures, problem-solving routines, and communication patterns constrain the space in which it searches for solutions. They actually used something called design structure matrix to analyze boundary and interface relationships between all kinds of different software. There's lots of detail if you go and read the original paper. We're not going to go through all that now. You'll be glad to know. Their key conclusion was, we find strong evidence to support the hypothesis that a product's architecture tends to mirror the structure of the organization in which it is developed. So that's for software. And there are other studies apart from this one, but this is the one that's we'll look at today. Back in 2004, there was a study looking at the design and manufacture of jet engines for aeroplanes. And they looked at problems that related to the where the boundaries of components were inside the jet engines. And in their conclusion, they said, we provide empirical evidence that product ambiguity exists, and it is more likely to be present across organizational and system boundaries. That's a quotation from their paper. Effectively, it's saying something very similar, that if there is a mismatch between the organization and the product architecture, there will be problems. And a further study in 2010 looking at the design and manufacture of cars, so automotive industry, from Gokbinar and colleagues. And in their study, they eventually concluded that mismatches, differences between product architecture and organizational structure are positively associated with quality problems. That means, again, if you have a mismatch between your organization and your product architecture, there's likely to be problems. Now, we can take advantage of this mirroring effect of Conway's law. And we can do that by using something called reverse Conway maneuver. Now, we should say very clearly, this is not some kind of thing you do on the highway. This is not something that you do with your car and do some strange maneuver. That's not what we're talking about. What we're really saying is we should design the organization to mirror the desired system architecture. So if we know there's a kind of system architecture which would help meet the business need and customer needs, then how can we set up our organization so it mirrors, so the communication pathways mirror the desired architecture? And if you think about it, this is basically heresy. This is basically, if I was saying this, I should be burned like a witch in the medieval period, in the Middle Ages, right? It's basically heresy. It's basically heretical compared to traditional software architecture, where we design it very carefully. We don't really think about the organization, and then we have people build this wonderful architecture. Turns out we actually need to design our organization and our software architecture at the same time. It's the same process, effectively, when we're moving at speed. What does this mean in practice? Let's have a little example. Let's look at an example of Conway's law kind of in practice. This is a simplified version. Just imagine, to start with, that we've got 4 software teams, A, B, C, D. They've got front end and back end, so front end in blue, back end in green. And there's a single database team, DBA, in orange. And within each team, the front end developer does some work and then passes it to the back end developer. They do some work and they pass it to the database team saying, hey, can you update the database? If this is the communication pathway in the organization, then let's just take this diagram and turn it through 90 degrees. The likely software architecture would look like this. We'd have 4 separate applications, but all sharing the same database. If that's what you want, that's fine. But these days, we probably don't want an architecture like that because it limits flow. The shared database would tend to cause bottlenecks. It'll tend to cause conflicts. We would tend to want an architecture that looks a bit more like this, where we've got independent databases for different applications or different services. If we want this kind of architecture, then let's change our organization architecture to match this. So what we're going to do, we'll take this diagram and turn it back through 90 degrees. And there we've got the organizational architecture. So we've now got a database capability or data capability inside each team. This is a very simplistic example, but this kind of tries to illustrate what we mean by Conway's law in practice. Ruth Mallon has won some awards for her work with software architecture, and she puts it like this: if the architecture of this system and the architecture of the organization are at odds, if they're different, the architecture of the organization wins. So she puts it even more strongly than Mel Conway in the original article. The key thing to realize here is that the design of the organization is really constraining the kind of solutions that we can find. So organization design is a constraint on the solution search space. Now that's kind of a strategic problem, potentially strategic problem. If we get the design wrong, if our organization's been set up in a way which may have had some good intentions, but it works against the architectures that we need, then this is really constraining the entire business, potentially constraining the entire business for finding the right kind of solutions. And what kind of principles should we have in 2020 and beyond when we're designing an organization? What kind of principles do we need if we have lots of software in the organization? If the software is a real key aspect of how our organization works. And these days now, software is a key aspect of many organizations. Even if you're not building or selling software, the software is a key aspect of it. So our starting point in team topologies is a rapid flow of change. We need to have a rapid flow of changes to the software systems on an ongoing basis. We are not building a piece of software and then shipping it. It's not discrete. It's a continuous flow of change, always on an ongoing basis. But it's not just change going in one direction. We need to listen to what's happening in the live environment, in production, and bring that information back into the organization for us to be able to change what we're doing in some way. So this old model of development, doing some work, and then handing over to an operational infrastructure team doesn't work. It doesn't work because in this handover point, things go wrong. In fact, in many organizations, there used to be many separate functions: development, testing, some kind of transition or release, live, and something would go wrong at each of these stages typically. And equally importantly, when we have many handoffs, this causes delays. This causes wait time. Effectively, we've got many different queues inside the organization, and that causes huge waiting time when we're trying to do something. So these handovers can kill a flow of change. So what we need to do is kill these handovers. What we need is a team that has end-to-end responsibility for all the aspects of a piece of the software system, not just the features, not just what the software provides, but the other aspects too, things like our ability to release it, our ability to test it, our ability to make it work well in production, our ability to support it. So releasability, testability, operability, supportability, all of these things need to be addressed by this team end to end. And so a product team, it's sometimes called a product team, has this end-to-end responsibility. They have all the skills and capabilities they need to be able to take it from idea, build it, run it, listen to the signals that are happening in the live environment, and bring that information back into the team to be able to improve things. And this has reduced all these, there are no handovers now. We're not handing this work to another team, which allows that fast flow of change. In the book, in the Team Topologies book, we call these teams stream aligned. These teams are aligned to a stream of change in the organization. And that's the starting point. If a team like this can build and run the system entirely by itself, then that's all we need. But typically in a larger organization, we end up having what's called a platform, which gives us certain kind of underlying capabilities. It might be relating to data, design, infrastructure, automation, this kind of thing. So that this team, the Streamlined team, can focus on the business domain or on the main thing that they're focused on. And they don't have to worry about the details of things that do not relate to their main focus. And we potentially end up with multiple Streamlined teams like this, sharing some aspects of a platform. But these streamlined teams are substantially independent. They don't depend on each other. We're not waiting for another team to do something. We've aligned the software architecture to have multiple independent, loosely coupled applications and services with a well-defined interface to a platform. So this is our organizational architecture and our team architecture. Sorry, organizational architecture and the software architecture at the same time. It's a diagram of effectively the same. The same diagram represents both the organization and the software architecture. Now, there's a limit to the size of these teams, and that's because there are natural human limits to our trust that we can have with other people. Robin Dunbar is a British anthropologist who has done lots of research in this space, and he talks about an individual's social network. We're not just talking about online media like Twitter and things. We're talking about their relationships with other people in the real world. And his finding, which is quite famous, is that an individual social network is typically around about 100 to 200 individuals. Usually the number 150 is used. So we can have meaningful relationships with about 150 people. Interestingly, Robin Dunbar has repeated this work in online social networks like LinkedIn and Twitter and Facebook and found a similar pattern. Typically, we actually only interact with up to about 150 other people in these different spaces. So there are many different kind of group trust boundaries that have been discovered through a kind of anthropological research process by people like Robin Dunbar. But actually, we can see some similar kind of trust boundaries if we look at the military. And you'll find a very interesting article called Social Inflection Points by someone called Ben Ford. Now, Ben Ford used to be in the British military, in an elite British military force. So he's got direct experience of what it's like to work in a high-performing team in a military context. He now works in software development, helping people to make their organizations more effective and understand kind of dynamics about software development. And he talks about these social inflection points that exist in kind of military groupings. In the army, for example, armies have had hundreds, if not thousands of years to find these kind of grouping sizes that work effectively. And he describes three at least. A group of 8 people in the British military is called a section, and that's roughly the size of a hunting party from kind of ancient times. A group of 30 to 50 people is called, in the military, is called a troop, and that relates roughly to a kind of tribe of people from ancient times. And a group of about 100 to 150 people is called a company in military terms, and that's about the size of a village. Now, here's what's really interesting. We've got that 150 number, which is the Dunbar number, the number of people that we can have meaningful relationships with. In the UK, in Britain, we have some very old records that go back to about nearly 1,000 years. And if you look back at these records, the typical size of a village in England at the time was 150 people. There was a census that happened and a set of records where people were counted. And so we've got data going back all the way many hundreds of years that suggests that these trust boundaries are very consistent in lots of different parts of human society. Okay, let's bring this back into kind of a software delivery organizational context. If there are a set of trust boundaries in place, this has a strong implication for how effectively we can organize the organization, how we can group things to enable a fast flow of change. If we want the fastest flow of change possible, we have to have the highest trust possible. And that's a group of about 8 people. That goes back to the social inflection point that we saw from Ben Ford, and that's that smallest grouping of 8, being proven by the military for many hundreds of years. That's the highest trust. That's going to allow us to deploy change the quickest. But there are other groupings that are slightly larger than that. Up to, we've got a boundary of perhaps about 100, about 50 people. What's that? That's several teams, but not very many teams. And there's another group at about 150 people. Again, that's several groups of teams, but it's not infinitely large. The key thing here is that trust dynamics can change when we're crossing one of these Dunbar boundaries or one of these social inflection points. And we should expect different kind of rules, different behaviors to emerge. We cannot just keep growing the team. We have to understand the effect of these kind of trust dynamics at play in the organization. So we cannot have, for example, HR or people department just assigning keep assigning more and more people into these groupings, because the trust dynamics will change. That will affect our flow of change. It will also start to affect the kind of software architecture that we're building, because we're growing some of these teams too large. And that has a direct then result on the likely software architecture that's going to emerge. There's a very interesting case study in the Team Topologies book from a company in the UK called AutoTrader. This is a few years ago, when they were rebuilding and refitting their office, their head office. They wanted to take advantage of Conway's law and this kind of socio-technical mirroring. They wanted to enable a fast flow of change in each of their 3 business areas. For the sake of the talk today, we'll call these different business areas private car sales, commercial car sales, and car leasing. And they wanted to have the fastest flow of change in each one of these different business areas. So what they did is they put everybody who was working on private car sales on the same floor, everybody who was working in commercial car sales on the same floor, and everybody's working on car leasing on the same level, on the same floor of the building. When I say everyone, I mean everyone. Support, engineering, operations, legal, HR, marketing, sales, everybody was in the same floor. So they were all focused on a flow of change in that particular business unit, in that particular area. They did not have a group of people for marketing or sales all sitting together working across these 3 different areas. They'd split it by kind of business area. It's a very interesting example of thinking about the effects of communication and trust boundaries at an organizational level when we're thinking about a fast flow of change. It also means we might need to take some care about how our digital communication, our online communication is set up. If we're using something like Slack or Microsoft Teams or something like this, that's the kind of the digital environment. What does that feel like? Well, perhaps we actually need to have separate Slack or communication groups for different parts of the organization, because otherwise we might not have the right kind of trust inside that grouping. We might lose trust because there are too many people inside that group. It's something that organizations are starting to explore now. Maybe you have a separate Slack for each of these 3 groups. It certainly means that it would keep those significantly separate. So crucially, we need to co-design. We need to design together the organization and the system architecture. So this is a joint effort between engineers, architects, and people who are making decisions about teams. So this is managers, HR people, facilities people, anyone making decisions about where people work in an organization, whether it's a physical building or whether it's a grouping inside a chat tool or a team boundary or something like that. We have to work on these things together. It's not possible, it's not sensible to separate them. And it's fundamentally then is a team first approach. So that gives you a flavor of why HR might be accidentally designing software architecture if we're not thinking about where people are placed. If we're not taking a team first approach, we might accidentally be influencing and designing aspects of the software system. So let's not do that. Let's take a proper team first approach, understand we need to design these things together, and take advantage of things like the reverse Conway maneuver to help us do that. So as I mentioned, the book's available online. If you go to teamtopologies.com/book, you'll find lots of bookstores all the way around the world selling the book. We're actually working currently on a workbook that's specific to remote teams, so remote ways of working like we find ourselves in now in the pandemic, where that will hopefully come out soon. We're working with IT Revolution, the publisher of the book, on this. And certainly initially at the beginning, it'll be a free PDF download. So if you'd like more information, then head to our website. There's lots of material and learning and videos and slides and all sorts of things like that on the website at teamtopologies.com. We do offer some remote friendly training. We've been doing that since March. So get in touch if that's something you're interested in. We've got some assessments as well. Lots of resources online. We've got a GitHub repository as well for some kind of templates and code and things like that. So you can send us a pull request and we'll get things modified. Free to use, freely available, kind of open source. So thank you very much. It's been great to be here. That's the end of my talk. I'm looking forward now to the questions.